This is Precalculus section 5.3, day 1 notes on trigonometric graphs. Before we start, you are going to want to grab at least 2 either colored pencils or highlighters. All right, we're going to start by graphing the parent graph for sine t. So you can see I've already made a table and I've strategically picked all the t values that go around the unit circle. So the sine values are just the y values that come from our ordered pairs at each of these locations on the unit circle. So I'm just going to fill these in quick. We can grab any of these right off of the unit circle. When t is 0, sine t is 0. At pi over 6, we have 1/2. Pi over 3, we have square root of 3 over 2. Pi over 2, we have 1. At 2 pi over 3, we have square root of 3 over 2. At 5 pi over 6, we have 1/2. At pi, we have 0. 7 pi over 6, we have negative 1/2. 4 pi over 3, we have negative square root of 3 over 2. 3 pi over 2, we have negative 1. 5 pi over 3, we have negative square root of 3 over 2. 11 pi over 6 is negative 1/2. And at 2 pi, we're back to 0. Now, some of these, I don't really know what these numbers are off the top of my head. For example, square root of 3 over 2. So if you grab your calculator and do square root of 3 divided by 2, that is 0.87. So this one's going to be 0.87. This one's going to be negative 0.87. And this one will be negative 0.87. Okay, so now I'm going to go ahead and I'm going to graph the points for this curve. So along my x-axis here, I want to count in terms of pi's. And as you can see, it's already been labeled here for me. So this is 0, and then we've got pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so when when t is 0, sine is 0. When t is pi over 6, which would be our first unit over, we're at 1/2. This is pi over 6. When t is pi over 3, we're counting by pi over 6 here, so each unit is 1 pi over 6. When we're at pi over 3, we're at about 0.87, so not quite up to 1. And then at pi over 2, we are at 1. At 2 pi over 3, we're back down to 0.87. At 5 pi over 6, we are back to 1/2. And then at pi, we are at 0 again. At 7 pi over 6, we're at negative 1/2. And then at 4 pi over 3, we're at negative 0.87. At 3 pi over 2, we're at negative 1. At 5 pi over 3, we're at negative 0.87. 11 pi over 6, we're at negative 1/2. And at 2 pi, we are at 0. Okay. So now if we go ahead and connect this, you will see what the sine curve looks like. Okay, that is what we call 1 period of sine t. So you have your highlighter, and you kind of put what I like to call the picture frame around this. Every time we graph trig functions, I'm going to talk about the picture frame. So right here, this is the picture frame for the parent function y equals sine t. Okay, so I'm going to write up here. Picture frame for 1 period of y equals sine of t. And my x values for 1 period go from 0 to 2 pi. And my y values for 1 period go from negative 1 to positive 1. So those are my domain and my range for 1 period. Now when I talk about 1 period, note that this graph, if I keep going beyond 2 pi, the shape is just going to keep repeating. The sinusoidal curve is just going to keep going. So this is just the graph for one period, okay? And also notice that our sine curve makes what I like to call a wave shape, because cosine makes a different shape. So sine makes a wave shape. Now let's take a look at the parent graph for cosine. So as you can see here, the values have already been put into my table, the same, the same values that you would get going around the unit circle, grabbing the x values from the ordered pairs. And I've already got the scale on my x-axis and on my y-axis, so I'm ready to plot the points. This time, when t is 0, cosine is 1. So it doesn't start at 0 like sine does. It starts up at 1. And then I'm at 0.86, 0.5. Then I'm at 0, negative 0.5, negative 0.86, negative 1. Then negative 0.86, negative 0.5, 0, positive 0.5, positive 0.86, and positive 1. We can go ahead and connect our points, and then we can see the shape that the graph of cosine t makes. It looks different. One period of cosine t looks different than one period of sine t. So let's go ahead and draw our picture frame in here for one period of cosine t. So our picture frame for one period of, y equals cosine t, our domain here for for our picture frame or for one period is going to be from 0 to 2 pi, and our range is going to be from negative 1 to 1. So same domain and same range as we had for the parent graph of sine t, but the shape is different. Notice that this has kind of what I like to call, since it's cosine and it starts with a C, I like to call it a cup shape. So I say that cosine looks like a cup and sine looks like a wave, and that helps you remember which graph is which. All right, now on the next page, we're going to start talking about transformations of sine and cosine. Just like anything that we graph, we can modify its shape by shifting it, by stretching it, by shrinking it. All those things that we would do to our graphs, we can do to our sine and our cosine graphs as well. So when we're translating up or down, that's when you're going to see that plus h at the end. And when you're reflecting it over the x-axis, that's when you're going to see a negative sign out in front of the function. And then that a that you see out there is going to be an amplitude change. And we'll talk about that in the next example. So I am going to graph my first example here, sine of x. I'm going to use red for this one so we can see the difference. Now it says sine of x plus 1. So what that plus 1 right here means is that we are shifting up 1. So we're going to shift our frame up 1. So what I'm actually going to do is I'm going to draw in my picture frame before I even draw any of my points, because once I draw my picture frame and I know the shape of my sine curve, then drawing the points becomes very easy. My picture frame, since I'm shifting it up 1, remember, normally my range is from negative 1 to positive 1. So if I'm shifting my picture frame up 1, now my range is going to be from 0 up to 1. So my picture frame is going to look like this. My domain hasn't changed. That is still going to be from 0 to 2 pi. But now my job is to just sketch that wave shape inside of this picture frame right here. So it's going to start up here. And then in the middle, I'm going to be crossing back at the center again. And then at the end, I'm going to end up at the center again of my frame. And then halfway here, I'm at the top. And halfway here, I'm at the bottom. And then I can just fill in the points in between And you'll get used to making this shape. The more you do it, you're going to do it a lot. You'll know exactly what it looks like. There we go. So I've shifted my frame up 1. Again, my domain has stayed from 0 to 2 pi, but now my range has changed from 0 to positive 2 instead of from negative 1 to 1. Okay, now my second graph, I'm going to do in blue. That graph is y equals negative sine of x. So that negative right there in front of the function is a reflection over the x-axis. But I want to make it clear, I'm not doing any shifting. So my frame does not move. Okay, my picture frame remains the same as the parent graph. So my picture frame is going to be from positive 1 to negative 1 and from 0 to 2 pi. So there's my picture frame for y equals negative sine of x. Now I'm reflecting it over the x-axis. So basically my graph is going to be flipped over. Instead of going up first, it's going to go down first. Just plotting my normal points here, but I'm flipping the graph over. So here's the graph of my sine curve with a reflection over the x-axis. And again, just in case you've forgotten, the parent graph, perhaps we should have started with that first. My parent graph here of sine normally would look like this. This is my parent here in green. So you can see what our transformations have done. Our first transformation just shifted our picture frame up. Our second transformation did not change our picture frame, but it flipped our graph over. The last thing we're going to talk about is changing the amplitude of the graph. That's that A number that you see in front of the function. The amplitude is defined as the absolute value of A. It refers to the largest value on the graph, and we will talk a lot about that as we go on. The A value either vertically stretches or shrinks the graph. So my last example today is going to be a graph of y equals 2 times cosine of x. My amplitude then is going to be equal to the absolute value of 2, which is 2. The reason the absolute value is there is because if there's a negative, that really isn't part of the amplitude. The negative is going to be a reflection, and the amplitude is just the absolute value of 2, which is 2. Okay, so what is this 2 going to do? It's going to double my picture frame in size for my y values. But only for my y values. My domain or my x values do not change. That's still going to be from 0 to 2 pi. So instead of going from negative 1 up to positive 1, now my graph, my picture frame, is going to go from negative 2 to positive 2. It's just going to be twice as tall. But once I draw in my picture frame, then I just have to draw my cosine shape. But keep in mind, the cosine shape has to fill that picture frame. The cosine shape is the one that looks like the cup. So it's always got a point here in the upper left corner of the frame and a point here in the upper right corner of the frame. And then in the middle of the picture frame, it's at the center